This video is on solving quadratic equations. We're going to be using the square root method for solving quadratics. The square root method is a little different than just factoring. So, although we can't get x alone algebraically when there's an ax squared and a bx term, we can occasionally solve quadratic equations algebraically when there is no bx term. So when solving an equation with an even exponent, like x squared or x to the fourth or x to the sixth, there will be two answers, unless one answer occurs twice, such as 4 and 4 or 0 and 0. So when we solve something that has an even exponent, we will undo that exponent by taking the root. So if this is a square, you will take the square root. So in this case, I'll take the square root of both sides. The square root of x squared is x, and we'll have equals. The way we have two answers is because we have a plus or a negative of it. Because so square root of 16 is 4. The reason this works is because a positive 4 times a positive 4 gives us a positive 16, and a negative 4 times a negative 4 also gives us a positive 16. So the key takeaway is when you take the square root or an even root of both sides, so that's the important part, of both sides, there will always be a positive and a negative answer. So we have both, a positive and a negative answer. So we actually use the symbol and we call it plus or minus. So it's written as a plus sign on top and then a minus sign on the bottom. So this is called plus or minus. And this happens when there's no bx term. So what we want to look at to see is, do we have a bx term? So if we look at this first question, it says to solve. That means we want to get the variable completely alone, and we want to get k or x alone, and we want to figure out the solution, so the x-intercepts, but we don't write it as a coordinate. So to solve means normally it should be equal to 0. But if we're going to use the square root method, we don't need it to be equal to 0. That's the difference between factoring and square root method. So if we look at this problem, we do have the letter k, and we have a k squared. But nowhere else in this problem do we have another letter k. What that means is that we can get this single letter k all by itself by just using SADMAP. We do not have to factor. We can just do a normal equation and solve. So let's just solve for this single letter k. By SADMAP, we're going to add and subtract first. We're going to subtract the 4 away from this side. So we'll have k squared is equal to 40 minus 4 is 36. Now we have the exponent, because there's nothing multiplied or divided, so we're going to have the exponent. We have to get the exponent away by doing the root. So this is a squared, so we'll do the square root. We did the square root of both sides, the left and the right, so we'll have k is equal to, since we did the square root of both sides, we're going to have a positive and a negative. So we're going to have a plus or a minus. And then the square root of 36 is 6. What that means is that our answers are actually k equals to a positive 6 and k is equal to a negative 6. These are the two separated answers, but we can write our answer as just k equals plus or minus 6. This is how they look separated, because we have one positive and we also have a negative of the same answer. And it's all because we can get that single letter k all by itself. So let's look at this next problem. Again, we have a quadratic, and there's an n squared. If we look at the entire problem, there is no other n in the entire thing. So that means we can get the single letter n all by itself. So using SADMAP, we're going to add and subtract. So we're going to add the 4 to the other side, and we'll have n squared equals to a positive 81. Now we have that exponent, so to get rid of the square, we take the square root of both sides. So when you take the square root of both sides, there will be a positive and a negative. So we'll end up with n is equal to a plus or minus then the square root of 81 is 9. So again, our two answers, if we wanted to separate them, would be n is equal to a positive 9 and n is equal to a negative 9. We can keep it as n equals plus or minus 9, but to see them separated would look like this. And this is, we don't have to have it equal to 0 because we're not trying to factor it. So in question 3, again, since we have a quadratic, look to see if there's any other letter x. We have an x squared, and in the entire problem, there's not another x. So we can get the single letter x all by itself using SADMEP. So we're going to add and subtract first. So we're going to add the 6 to both sides. We'll have 7x squared is equal to a positive 63. We still have to get the x by itself, so we're going to multiply or divide. So that means we're going to divide both sides by 7 because we're using SADMEP. We can't touch the exponent until we get everything else away. So we'll have x squared is equal to 9. Now we can get to the exponent. So to get rid of this exponent, we would, since it's a square, we would square root both sides. We are square rooting both sides. So we're going to have a plus or a minus, a positive and a negative. So x will equal to a plus or minus. And then we take the square root of 9, which is 3. So to write our answer out, we would have x equals positive 3 and x equals negative 3. But we can keep it as x equals plus or minus 3. You got to be very careful about knowing that you have to put that plus or minus. So on question 4, again with the a squared, look to see if there's any other variable in the problem. And there is not, so we can get the single letter a all by itself by using, again, SADMEP. We're going to add and subtract first, so that's that 4. We're going to subtract the 4. 8 minus 4 is 4 equals 4a squared. Then we're going to multiply or divide away. We're going to divide by the 4. So we have 1 equals a squared. Now we can focus on the exponent. Get rid of the square by taking the square root of both sides. Since we took the square root of both sides, there's going to be a positive and a negative. So we're going to have a is equal. So we're going to have a positive and a negative. The square root of 1 is 1. So again, our answers would be a is positive 1 and a is equal to a negative 1. Now, these questions, we still could have factored them. And this next problem, we're actually going to factor that first one to show you that you'll get the same two answers. So we're going to solve number 1 by factoring. So I'm going to rewrite question 1. We're going to have it's k squared plus 4 is equal to 40. Now to solve by factoring, you actually have to get it equal to 0. That means I need to move the 40 to the other side. So in order to do that, I'm going to subtract the 40, and this will turn into k squared minus 36 is equal to 0. Now I'm going to factor this. This, since we have two terms, we look for what's called a difference of squares. So I have a perfect square. K squared is a perfect square. 36 is a perfect square. And I have a subtraction sign. That means that we have a difference of squares. We have a difference of squares. And that helps me because I can take the square root of k squared, which gives us k, the square root of 36, which gives us 6. So this will factor into parentheses k plus 6 and k minus 6, and this will be equal to 0. That's the whole point of difference of squares. It factors into something perfect because we have perfect squares. Now, since I have it set equal to 0, I can use the zero product property and set my two factors equal to 0. So I have k plus 6 equals 0, and I have k minus 6 is equal to 0. If I solve these, k plus 6, I would subtract 6, so k is equal to a negative 6. And if I were to add 6, I would have k is equal to a positive 6, which are the exact same answers that I had from solving by the square roots. I I get the same answers even if I factor them. It's just that solving by square roots can sometimes be much quicker and a little bit easier.